Information in 8 minutes. Hello QBE team, and welcome to Information in 8 minutes, which is a series of videos which at the moment is one video and it's not 8 minutes, but hey, this is a lot harder than it looks. So without further ado, enjoy the first video, which is Introduction to Information Architecture. It's more than 8 minutes though.
An overview of information architecture. Let's start from the beginning. What is the purpose of information architecture? Well, for such a complex subject, it's a fairly straightforward purpose. It's all about getting information from one person's head into another person's head, and a little bit further on down the supply chain into other people's head, making sure that the information can be propagated successfully and effectively. How can we achieve this? There are a number of different ways, and in order to make this a little bit more simple and easy to understand, we've divided this up into 4 main areas. The first area is about defining your information or your data. And it's about making sure that you've got a clear, consistent definition of what it is you're discussing, how it interacts with the rest of the world, and what its functions are. We then need to cover using information. So how do we understand the purpose of information? How do we organize it? How do we find it? And how do we build it? We do really need to understand communicating. This is an absolutely critical point. Communicating information takes information on a journey through waypoints, between stores, cross interfaces, and as it's transformed from one form of content to another. And finally, and probably most importantly, is about governing information. These are the rules and the standards that are applied to make sure that the people on the receiving end can understand they're getting the best quality information that they require. So let's start with the first thing, which is defining information. There are various tools for defining information, and if we look at the first one, the key one, dictionaries and glossaries are used for meaning. So this is making sure we can standardize on exactly what we're talking about, being able to compare apples with apples and oranges with oranges. Relationships are key, so for this we might use data and information models, as in the top right hand picture here we've got a party framework, and this shows us the relationships between different types of information, different sets of information. We may use process maps to define our functions of information, and in the bottom right hand corner you'll see a business model from the Archimate language, which allows us to define the context within which information is used. And this is set in a business and application context here in this particular diagram. At this point, it's probably worth exploring why meaning is so important. If we think about information and data within an organization, it's frequently a bit like this Rubik's Cube. It's fragmented, it's not ideal, and different silos have different understandings of what they're looking at. In order to get around that, we need to break our data and information down into the component parts that we're going to build meaning with. And these are defining the terms that we're using and making sure they're consistent across the different parts of an organization. We can then use these building blocks to build something that gives a consistent view no matter what your perspective. And as it says here, make sure our communication is in harmony. So moving on. We're moving on now to using information, and key to this is the purpose. So for particular sets of information, there will be a purpose. For all sets of information, there should be a purpose. And in order to identify that, we need to start at the end of the information journey with the end person. So one of the tools that we can use this is a Zachman framework, which gives us the who and the where and the when and the how and the what. But we always start with the end person because they're the end consumer. This particular model, the Zachman framework, is based on a model from a librarian called Ranganathan, who was alive and active in the 1930s. So it's not exactly new, but it's very effective. Once we've identified who's going to use the information and the purpose they're going to use it for, it helps to understand how we're going to organize it. In order to organize it, we'll use library science to group and classify information and data. So I'm going to present 4 different classificatory structures here. They each have different purposes. So the first 2 are hierarchies and trees, which are contain at the moment an entry about crows, or the crow family, Corvus. And you can see that on the hierarchy side, crows, rooks, ravens and jackdaws are all types of corvus. They have inheritance. Whereas with a tree, the wing, beak, feathers and feet aren't types of crow. They're just component parts. Another classificatory structure is the table, and we might use this for decisions, for example. And in this again, I've stuck with crows, so you can see that we identify a rook as having black plumage and a long tail. The final type of classificatory structure is facets, and we typically use this for searching. So what you can see here is we've identified a number of different facets for crows. In this case, there's only 4. There's obviously a lot more. But each of these classificatory structures has its own particular use within information architecture. We might use hierarchies when we're establishing reference data tables. We might put trees together when we're doing mind maps. Tables can be used for decision logic, and facets are typically used for searching. An often underappreciated part of information architecture is the journey of discovery. And this is about basically being able to find things. So typically this starts off with a question, and then there's a journey during which we hope we're going to get somewhere to an answer. And typically this would be by searching or browsing. So we have 2 mechanisms here worth discussing in detail at a later point. Google is a good example of using metadata. We'd search for something using Google. We'd use metadata. We have an idea of what we're looking for, and we'd use search terms. Another way would be to have information maps or info maps, and this would enable us to browse. So we're not necessarily sure what we're going to look for, but we do have some interesting info map panels here and here and so on. And these would allow us to browse through the information that's available and find what we're looking for. And it's worth pointing out, if users can't find the information and data, then there's not really a lot of point in having it. Tools for helping us with this are metadata and info maps. So this might be a search engine, or it might be something as simple as a file structure that allows us to find it. And let's not overlook the people aspect here. People who know where to find content are usually very valuable. The next stage of our journey is to understand processes. Now, I always think of processes as the business context in which information needs are framed. If we think about a business to IT stack, it carries from business architecture, the people who decide what's required, and it continues through processes all the way down to the tin that the data is carried on. The key to this is the fact that we start at the top with the people and understand what their requirements are. We would express that as processes, and then from that we can build our information requirements. So typically we need to think about where the people are in this and where the machines are. A lot of organizations start down at the machine end of things, in the applications and the infrastructure, and then try and build information architecture from that. Clearly this isn't the best way to do it. We need to think about the people first, and then how they go about gathering it and storing it and what they use it for. In order to do this, we need to develop process maps. If not on pieces of paper or in Visio, then at least to have an understanding of what the processes are. Communication is the way by which we move information and data, and this can be between people's heads, it can be between machines, it can be from people to machine or machine to people. It's all about the movement of data and information across time and space. Typically we'd think about this in terms of waypoints and channels and crossing interfaces. And the example I've got here is just of a conversation. So information is spoken, it has a simple journey, no waypoints, one channel and one interface before it reaches the other person's ear. And I'm using these terms, so let's just make sure we have a clear understanding of the definitions. Waypoints are a stopping place on a journey. They don't necessarily have to have any other function other than the fact that they're a stopping place. A channel is a path to deliver payload. So you might, for example, have a delivery channel or a marketing channel or any other type of channel. It depends on the payload that you're trying to transmit down that channel. And an interface, well, an interface is a shared boundary. And I've got between things here, but we can have between person and machine. We can have between functions, across organizational interfaces. So for example, if you send out an email to a third party, you'd have an interface between those two. Information architecture needs to take into account long journeys as well, with multiple waypoints, channels, and interfaces. So if we consider the example here of weather data being collected by a weather sensor in order to be used by an insurance company where a claim's been made for damage to a roof because of a storm, there's a significant path across different interfaces through different channels before we get to the conversation that a claim center might actually have with the customer about that weather event. We do have a whole set of different tools for communication, and it's worth at this point dividing these up between information and data communication. So typically here I mean information as in people to people and data as in machine to machine. We might have for information communication touch points, user journeys, and interface designs, anything where the person is the central focus of that communication. For data, this is all about machines, and typically we'd have this in ETL applications or mapping documents or anything where we're going to be just focusing on the data. The final area of information architecture we're going to consider in this short video is governance. We can think of governance as a three-legged stool. You need all three legs in order for it to work properly. The first leg is policies, principles, and standards, or other governance mechanisms that people might use. The second is the people to use them. And then finally is the evidence that we would provide to end users or other people in order to say that, yes, we've actually applied these things. And that gives us trust, and that's what the outcome we're aiming for. So each of these has a very particular definition, and they're all on a spectrum. We start off with principles, which are defined as a general course of action everybody should follow. We go to policies, which are written articulation, and then finally we have standards. Now imperatives are clearly you must do. So if you think about this in a spectrum from you should to you must, you can understand where these three different governance mechanisms sit. Finally, a brief overview of the information lifecycle. Now this applies to all types of information, no matter what, whether it be data, information, knowledge, wisdom. And these are all terms we'll explore in a later video. But the information lifecycle is composed of 6 basic stages. These can be enhanced depending on what sort of information that you're talking about, and these can also be repeated in little loops. But from start to finish, it works like this. We define need for information or data. We then create it or capture it. Frequently, we would do both together. Then it gets stored. It gets distributed. People access it. And by access here, this isn't just about having access to a particular file. It's being able to make sense of it and then have some reuse. So just to explain the difference here, if somebody had access to a file of customer records, but they were all in ancient Greek, then the chances are, unless they understood ancient Greek, they wouldn't have accessed it. They would have something that they weren't able to reuse. So access is being able to reuse and learn from. Finally, we have final disposition. So this could be thought of as either destroying the information, or it could be repurposing it, or it could be putting it in an archive somewhere. Now again, if we think about different situations, there are different stages of the life cycle which can be used in different ways. If we think about somebody who's hacking into our system, for example, we've stored it, we haven't distributed it. A hacker would then come along and they would move back to stage 2, which is capturing it. They might then store that on their own machine for future sale. But the point is, the information lifecycle itself is expandable. It's reusable in different parts. Principal tool for the information lifecycle is a checklist, and this would be typically done by attitudes of risk and aspects of control. So, in summary, the purpose of information architecture is to get information into different people's heads, and we can achieve this by focusing on these 4 areas.